What's up? I can't hear you. They're all talking. Tell them shut up. Around, 11. Why? To go to track? Gotcha. They'll probably send me an email. Yeah. Usually they send an email with the list of students who have to go to that thing. And actually, after today, you'll know what we're doing on Friday. I'll explain in a moment. So first and foremost, let's talk about the timeline because I haven't seen you guys in a week. So I moved the camera over to take a look at the calendar for June. First and foremost, I have you today and I have you Friday of this week. Obviously, today I only have you for a little less than an hour. Friday, I have you for that full class period, which, yes, would be 11 to, when does class period end? Oh, 12:22 or whatever, right? Yeah. And you guys are leaving for track at that point. Yeah, they'll make that announcement. We'll figure that out. The goal for today and Friday and for Tuesday of next week is to review for our final exam. We are beginning the official review for the final exam today. I do have a review study guide that I'm going to give you, that I'm going to send you via Google Classroom, and we are going to diligently work through it problem by problem, answering whatever questions we have in preparation for the final exam. You will be taking your final exam on Thursday, June 10th. Thursday, June 10th, you will come to class. We will have the Chromebooks ready to go, and you will be able to log on to Linkit and be able to knock out this final exam. The exam has to be taken during that particular class period. I will make the information available to you during that time. You okay there? What's he doing? What's he doing? Oh, you're trying to get into a selfie picture?
No, I was trying to do something. No pictures in class, Declan. Trying to get a photo of you. Yeah, that's why.
Oh, of him?
Yeah.
Why?
In that case, I tried getting his reaction.
Great. Anyway, back to this. Now, again, when you take that final exam on Thursday, June 10th, yes, we'll officially be done with class. I do have you again on Wednesday, the 16th. Those are for the non-seniors. Non-seniors, I have you again on Wednesday, the 16th. Mr. Markey, do we have to show up that day? Yes, I am going to be taking a regular attendance. And if you don't show up, I'm going to have to mark you absent. Yeah.
Stupid.
I gotcha. Well, I'm just saying, if you're absent from school, then you're absent. No big deal. But, I'm just saying, I'm taking a regular attendance that day. I'm just being very upfront with you guys. Yes. I'm sorry. It would only count if you are a virtual kid. See, what happens is when students are absent and they log in virtually, I appreciate that. I do. But if they're not virtual in Genesis, I still have to mark them absent. But I do make the note that they were in the live stream. That's just for my sake or for other teachers' sake, or for if eventually there's a dispute and like somebody has to go back like a month later and be like, oh, well, this student should have been virtual, but they weren't. But then you can see they were in the live stream. Then they can use that as evidence. But that's neither here nor there. And then you all remember what's happening the 18th, right? The 18th is that day where you go to all 8 class periods for like 15 minutes. Yeah, you go to all 8 class periods for like a brief amount of time. It's a half a day, and basically nothing gets done, and it's chaos. It has to do with like the 180th day of school or something like that. I know. It's like state law dictates that you have to have 180 school days or actual, like we did the virtual ones, those counted for this year. Even the snow days, like, when we had a snow day, we still had a school day, whatever. Anyway, but graduation can't happen unless you have 180 days of school. There was a controversy a few years ago where they had scheduled the graduation for like a Tuesday. And then the last day of school was supposed to be that Thursday. But it turned out that Tuesday, because of the snow day issue, that Tuesday was only day 178. And legally, they were not allowed to graduate. So they had to push the graduation back to that Thursday. And parents were so mad. So mad. Yes. This is in Barnegat a few years ago. Yeah. So they learned their lesson. Just saying. Stop taking peeks at him. I don't think he appreciates being oogled. Anyway, like I said, as for today, we are going to be working on the review. Now, lastly, before I send you this review, in order to wrap up series and sequences, well, we wrapped it up last class period, last week, and I said that I want to just have a brief assessment on it. I am going to be sending you today a quizzes to wrap up sequences and series. That quizzes you will have 3 attempts at, if you so choose. You don't have to use all 3 attempts, but you will have 3 attempts at that particular quizzes. It should be a fairly straightforward quizzes. You can pretty much just follow the notes that you have taken and the sample problems that we have done in order to answer said questions. It should be fairly straightforward. But I will be sending you that quizzes today. You will have 3 attempts at it, and that will wrap up sequences and series. No. I'm counting it as a minor. I wouldn't do a multiple choice quizzes as a major. That would be cruel and unusual. I'm going to take care of that. Don't worry about that. You guys will be taken care of. So, yes. Yeah, real quick. I'm going to send you guys something now. The PDF for the final exam. Click post. For those of you that are online, if I haven't asked for it already, I don't think that I have, but if you can please leave a comment in the chat. I do see the 4 comments that have been left so far. That would be absolutely wonderful. In your Google Classroom, there is a final exam review that has been posted that looks like this. Now, this is the final exam review that the other Algebra 2 teachers are also going to be using in preparation for this Link It final exam. Again, we do have 3 class periods to go through this: today, Friday, and Tuesday of next week. My objective is to go through every single one of these problems to tell you exactly what is expected of you so that there are no surprises on this Link It final exam. So, whatever you need to write down, whatever you need to jot down as a reminder, as a, oh, that's how I do this problem, oh, that's what I have to study, I would strongly suggest that you do so. Because obviously you don't have a physical copy of this exam review, but you are getting a PDF version of that. So, again, this is the review that all the Algebra 2 is going to be using. As they say, reminder, the exam counts for 10% of your overall grade, blah, 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 But we'll go through this a step at a time. Now, in terms of me, I'm going to be going through these problems, but I am also going to be jotting down some information for myself, working through some of these problems, showing you how you can actually do the math for them. And like I said, whatever we end up not finishing today, we have Friday and we have Tuesday of next week. So we will be able to get this thing done. Come on, this thing. There we go, much better. Just want to make sure this is all lined up for me right here. There we go. Focus there. And just for my own sake, for my own notes, I'm going to, this isn't official notes, but I'm going to do this for my own organizational purposes. I'm going to put my little information down there. I'm going to pick a new pen here. I'm going to pick, ooh, this one might work. Yeah, I'll use that one. Ah, it didn't make it. Okay. I will call this final exam review. There we go. And there we go. Japan. Okay. So number 1. It says to let f of x equal that quadratic. Try to zoom in on that. But again, of course, you do have the PDF for those of you in the live chat. For number 1, it says that f of x is equal to 2x squared minus x plus 1. And it says that g of x is equal to x minus 4. They want you to do 3 things. They want you to find the roots of f of x. They want you to divide f of x by g of x, identify the remainder, and they are asking the question, is g of x a factor of f of x? So first, let's start by finding the roots of f of x. As a reminder, roots are the exact same thing as x-intercepts. It's the exact same thing as zeros. It's the exact same thing as solutions. They all mean the same thing. They are all identifying the same thing on that particular quadratic. So in order to actually find the roots of f of x, I'm going to take this 2x squared minus x plus 1, and I am going to set it equal to 0. There are two main ways to find these solutions to a quadratic. You could either use the quadratic formula, or you could attempt to factor. Factoring may or may not work. Quadratic formula will always work. If I'm going to attempt to factor this, first I'd attempt to take out a GCF, which there is no GCF to take out of this problem. I would multiply a times c to get 2. And I would think to myself, can I actually find 2 magic numbers that fit this situation? Can I actually find 2 magic numbers that multiply to 2 and add up to -1? It shouldn't take that long to realize, oh, that is not actually possible. This is not possible. This is not factorable. But just because something is not factorable does not mean that you still cannot find the solutions to that problem. In order to find the solutions to that problem, you are going to have to, you have no choice now, you have to use the quadratic formula. So again, we haven't written this down in quite some time, so I'm going to strongly suggest again that you do. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. Move that up a little. There we go. Now, this is a little bit of a long shot because, again, I don't believe we've used this word in quite some time, but does anybody happen to remember what we call that thing inside of the square root? It's been a while. That b squared minus 4ac actually has a special name. Like I said, it's been a while. That's why I kind of prefaced that question. It's called the discriminant. It's called the discriminant. The discriminant can help you determine whether or not something is or is not factorable, which we already know it's not factorable based on the fact that, well, we can't find 2 magic numbers that multiply to 2 and add up to -1. It's not possible. So it's not factorable. So we do have to end up using this quadratic formula. I'm going to plug in the numbers where they're supposed to go. -1 is my b value, plus or minus the square root, -1 squared, minus 4 times 2 times 1. The whole thing is over 2 times a, which is just 2 times 2. I'm going to zoom in on this section of the paper. Here we go. What ends up happening, if you simplify this correctly, you're going to get 1 plus or minus the square root of -7 over 4. Oh, that is disgusting. That is absolutely disgusting. But this is what happens with these numbers. This is just what happens when these numbers are put into the formula, and we are forced to do something about it. We can still find the solutions to this thing, but that negative is going to have to be taken care of. Again, it's been a while since we've seen this. It could possibly have been January. No, probably December since we've seen this. Again, it's been some time, but them's the breaks with these problems. What has to happen is the letter I. What has to happen is the letter I. Here's what you do. That negative comes out of the problem as an I, because you can't take the square root of a negative. And in all honesty, this is all that you can do to the problem. This is it. I'm going to recap what the heck just happened, but I just want you to take a look at this. That negative is really the square root of -1. The square root of -1 just becomes an I, so that negative transforms into an I because you're taking the square root of it. Nothing else really changes. Everything just kind of stays where it is because nothing else can be simplified on this particular problem. So, recapping, they wanted you to find the solution to this quadratic, f of x. I tried factoring it, unfortunately could not find any magic numbers. I had no choice but to rely on the quadratic formula, which took me down to the route of I, and unfortunately I get this disgusting looking answer, which that's the answer. There's nothing else we can do about that. So now, what does part B ask for? Part B on this thing now says to divide f of x by g of x and to identify a remainder. Well, I'm going to remind you of something here, because this is something that, again, may trigger some memory of some sort. We're going to have to take 2x squared minus x plus 1 divided by x minus 4. And they want you to identify a remainder. So now I want to bring you back to this. Visually, this bar should look familiar. Oh, I vaguely remember that from long ago that we did that. Yes. The numbers that go inside of this bar, which, by the way, this is called the synthetic bar, the synthetic division bar, is for dividing polynomials. The numbers that go on the inside are the coefficients from the actual equation, 2, -1, and 1. If there was a term that was missing, we would have to put a 0 in its place. But we're not missing anything. It's got the x squared, it's got the x, it's got the constant. We're good to go. The number that goes on the outside, however, has to be the 0 of what we're dividing by. The 0 of, in this case, x minus 4. We have to put a positive 4 there. We have to put a positive 4 there. X minus 4, if you set it equal to 0 and solved, would give you a result of positive 4. This is the setup for the synthetic division bar. It will help you divide this polynomial. The way that it works is repeated addition and multiplication. Again, it's been a while. The first number just comes straight down. Then we multiply. You always multiply by the number on the outside. Then you add. Then you multiply by the number that is on the outside. Then you add. What the heck is this number? What the heck is this number right here? Again, it's been a while. We probably last saw this stuff pretty much in January, February. Yeah. Do you remember what number we kind of hoped we would get in this position? What number we kind of hope we get this number, because if we get this number, it kind of points to like, oh, we might be doing it right. We were hoping that we would get a 0. But this number right here is your remainder. This is your remainder. If done correct, I mean, if the function can actually be divided, if the function can actually be factored, and you divide it by the proper factor, then yes, you would get a remainder of 0. Like, oh, 28 divided by 7 equals 4, remainder 0. Yay! But no, we got a remainder of 29. We didn't do anything wrong. We did not do anything wrong. If I go back to the action, divide them and identify the remainder. Well, I get a remainder of 29. I get a constant of 7. I have an x term of 2, meaning the result is 2x plus 7, remainder 29. That's the result of this particular division. The last number represents your remainder, and then working backwards, it would be constant x term, x squared term, etc., if there was one. But in this case, it was just 2x plus 7, remainder 29. We were hoping it was a remainder 0, but we got a remainder of 29. That's the answer to part B. You divide them and identify the remainder. Part C, is g of x a factor of f of x? No. G of x is not a factor because we did not get a remainder of 0. We did not get a remainder of 0. The only way that you're going to be a factor in this division concept is if you actually get a remainder of 0. That's the only way you're going to be a factor, a proper factor. So because you get a remainder of 29, sucks to be you, but you're not a factor. Oh, synthetic division, the synthetic division bar and all that it did allowed us to divide and properly factor higher level polynomials and such. Crazy times. What comes next? Now, this review is going to jump around a lot. It is going to jump around a lot, but we're just going to brute force in order. Number 2. You buy a car for $641.85. Okay. So you buy a car for $641.85 and it depreciates at 23% a year. Set up a model for value of your car in T years. What will the car be worth in 20 years? Okay. This takes us back to the exponential chapter. This was chapter 7 in the textbook. Stuff that we did mainly in the 3rd marking period. But they want to know, okay, first let's set up a model. The model that you need is this. Again, this is something that we haven't seen for quite some time, but this is, if it'll actually focus on my screen, there it goes. This is the decay exponential. This is the decay exponential model. A represented the initial value. The initial value in this case, you bought it for $641.85. They're basically saying, okay, let's just pretend that's the value you're starting at. And now the car is going to lose value at 23% a year. R represents the rate, either of growth or decay. In this case, it's a decay, which is why I have 1 minus R. The X represents time. Time could be measured in anything. It could be measured in years, minutes, seconds. It literally could be measured in anything. In this case, it is measured in years because it's 23% per year. Y is just the resulting value. The model that they want is something like this. Now, you could write this out in a number of different ways. In fact, you could simplify this if you wanted to. To be 1 minus 0.23, you could write it as, in the parentheses, you could write it as 0.77. And that would be acceptable. But this is what we get. That t is just the number of years. They just wanted me to do the number of years. And then they say, okay, well, what will the value of the car be in 20 years? All right, 641.85. I'll do the 0.77 right here to the 20th power. Oh, I can't see that. Move that over. There we go. I think they did say 20 years. Yep. What will the car be worth in 20 years? Go to my calculator. 641. Boom. Oh, crap. That sucks. But that's the way the math works out. The car will be worth $3.45. It's kind of unrealistic. You could always scrap it for more than that. You know how much like mechanics are offering just like to scrap your car? Like a couple $100s. Yeah. A good mechanic will offer at least a couple $100s just to scrap your car because they just want the parts. Yeah. A couple times. Yeah. No, it's just a couple $100s. Like who? Well, think about like an old junker car. You're not going to be able to sell it for thousands of dollars because if it's an old junker car, someone's going to have to take that car and actually like it back up. They're going to have to take the time to spend the money to fix it. Because I don't have the patience or the know-how. I do know everything. Why not? I don't have the patience. I could. Could you? Oh. Sometimes I'm a patient in the hospital. Huh? Whose kids? I have kids. Number 3. Find the product of that calculation in its simplest form. I'm going to write this thing down and then flip my camera over so that you can see exactly what's going on here. And I need to clarify something very, very important to you. For number 3, they want you to, wait, what were the words they used? Find the product, meaning multiply these two things together. Do not try to butterfly this thing. Do not try to butterfly this thing. I've seen people try it before. You only butterfly when you have a fraction equal to a fraction. You only butterfly a problem like this when you have a fraction equal to another fraction and you're trying to solve. No, you're not trying to solve here. You're trying to just multiply these things together and simplify. And when you do that, they typically just want you to multiply straight across. Top times top, bottom times bottom. I say typically because there's something that we can do first. There's something that we can do first. And in fact, I'm going to do it right here. I'll show you what that change was in a moment. I'll show you what that change was in a moment. The change that I'm going to make is this. And I wrote that in red, so it's a little bit more noticeable. If you see what I changed in red for this problem, I factored the top left portion. I factored the top left portion because now everything's being multiplied and divided. I can simply do this to the x minus 2's, which is nice. Now, if you wanted to, you could simplify farther with the 6 and the 2, but just for the sake of argument, top times top, bottom times bottom should be 18 over 2, which reduces to a 9. 9 is the answer to this problem. That's all that you would have to worry about with a problem like this. Factor, cancel things out if you can, see where the problem takes you. That's number 3. That was what we did in rational functions. That's what we did in chapter 8, I believe. Simplifying rational functions. We had an edge elastic assessment on this stuff. Let's take a look at number 4. Now, they do have some probability in here. It's interesting. On the benchmarks, you guys remember the benchmarks and how much we suffered through them? Yeah, the benchmarks were ridiculous. Linkit made the benchmarks. And for some reason, and I've complained about this to my colleagues, I have complained about this to my supervisor, I've complained about this to whoever will listen. The Linkit Algebra 2 benchmark is a load of flaming garbage. It is. Because on the benchmark for Algebra 2, they're just like, don't worry, it's stuff that you'll get to. I'm sorry, there's AP statistics level questions on that benchmark. It's not. Like 9 out of the 35 questions. Yeah. Why do you think on the benchmark, people were getting like 20s? Well, yes, partially because touche. No, but the reason why I'm so upset about it, and I'll tell you exactly the reason why I'm so upset about it. Somebody argued, well, listen, if we want them to take the benchmarks seriously, we need to make the benchmarks count. But that's not up to us.
Make them count. Then why don't they give us material that we know?
Thank you. Well, no, I liked your solution better.
But like not stuff that we're going to get to, stuff that we've already learned up to that point.
Per se. Or why not in Algebra 2, give you guys, like in the beginning of the year, give you guys like a benchmark on like Algebra 1 geometry stuff to see how much you retained.
Yeah, that was in also, I think at the very beginning of the year, she would review it.
That's also true. Yeah, no, I agree. So it's just people being like, how do we make them do better on the benchmarks? Because apparently the benchmarks determine something at the board level. I don't know.
It's just some stuff in the school.
Just one load of garbage though. But it's not like a teacher decision. It's not even my supervisor's decision. My supervisor's getting this crap from up above.
It's like the board.
It's mainly the board office and the curriculum department.
Aren't the parents on the board?
Yes, but the board works hand in hand with the curriculum director, and the superintendent. They're the ones that make the decisions.
So the curriculum, blah, 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 and the superintendent.
Yes.
Maybe we should all like write letters to them.
It won't work. They basically get their jobs by appointment from the Board of Education.
But and like the board of education, I know a lot of them are made up of parents.
Yes.
Students in schools, like they want their children to suffer.
You would think that it was mostly parents, and for the most part they are, but then a lot of them are just not. Anyway, back to this. Number 4. Yeah. One bag contains 2 green marbles, 4 white marbles. A second bag contains 3 green marbles and 1 white marble. If Trent randomly draws 1 marble from each bag, what is the probability that they are both green? I'm going to give you the easiest, absolutely easiest way to think about this particular problem. Very easy, trust me. Oh, we'll see. I once had a bag of marbles in this room that I could have used as an example, but I seem to have misplaced it. I know, but I misplaced them. They're somewhere in the room. I don't know where they are. They're somewhere. I don't know where they are. I've misplaced them. There you go. There you go. There you go. Yeah, I was waiting. So I'll show you what I'm writing down in just one moment. I just want to make sure I get this written down first so that we can see the separation, because I know what happens. When you guys read a problem like this, you typically like zone out after the first couple of words. There we go. This is what I wrote down for this problem. Bag 1 versus bag 2. The composition of bag 1 versus the composition of bag 2. It's easy to get a visual when you actually like separate them like that. The dude's going to pick 1 marble from each bag, and they want to know if what is the probability that they will both be green. So green and green. It's as simple as just multiplying them together. There are 6 marbles in the first bag. 2 of them are green, which means 2 out of 6 are green. In the second bag, there are 4 marbles, and 3 of them are green. 3 out of 4. All you have to do, and you can be the judge as to whether or not this was easy peasy, is just multiply these 2 fractions together. This word "and" implies multiplication. If I multiply them, 6 over 24 reduces to 1 over 4. That is the answer. I don't know, Declan, what do you think? Is that easy peasy? What level of easy is that?
I like solid. Level 2.
Out of what?
2.
2 out of 2?
Yeah.
But yeah, it's a lot of words. And I guarantee you, when people read a question like number 4,
It's just words.
yeah, literally, that's all they see is words. And there's like words. They kind of read it and they're like, I don't know what's. That's why I like to draw stuff like this. Literally separating them into each bag, getting the visual of, okay, here's the composition of bag 1. Here's the composition of bag 2. The question that they're actually asking, Trent's going to randomly draw a marble from each bag. What is the probability that they're both green? Green and green. 2 out of 6 in the first bag, 3 out of 4 in the second bag. The word "and" implies multiplication. That's what this problem comes down to. You missed an amazing marble joke. Huh? I used to have a bag of marbles in this room for like teaching purposes, but I seem to have misplaced it.
Is that the joke?
You gotta think about it.
Did you like drop them or something?
No, I just misplaced them. They're somewhere in the room.
Marble?
Yeah, I don't know where they are.
I don't get it.
What happened to his marbles? He doesn't know where they are. He lost his marbles.
Oh,
There you go.
I get it.
Number 5. Now, number 5 is somewhat of a straightforward problem, but again, words. It's about deciphering words. If you can decipher what the question is actually asking, then I can help you to understand what you have to do for this problem. There's a random sample of 240 people, blah, 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 blah. What do they prefer? Do they prefer an SUV? Do they prefer a sports car? The table is broken up into male and female. It's a fairly straightforward premise, but the issue that people have is when it gets to the actual questions. First of all, what percentage of survey takers was female? Answer me this question. First of all, how many total people took this survey? Who? How many total people took this survey? 240. How many out of the 240, according to the first question, how many out of the 240 were female? 180. But that's what I'm saying. It's like you can decipher what this table is saying. But the problem is you have to first decipher what the question is asking. That's the problem. That's the main problem. So for part A, they want to know what percentage. I literally just have to divide those. 75%. 0.75 or 75%. Yeah, that's part A. Now part B obviously gets a little bit dicier. What percent of the participants preferred an SUV? Actually, no, that's not dicier. That's not dicier. There are 240 of them. How many of the 240 wanted an SUV? Yay! So part B is just 156 out of 240. The next one will get dicier. We just recently purchased a small SUV. Because we needed one. My old car, well, we traded it in. We scrapped it. Yeah, but not a lot. but we purchased a mid-size SUV from Carvana.
Did you need it like fixed, or like did you just want another car?
Oh, the amount of money that it would have taken to fix the car was way more than the value of the car.
My dad just fixed it for you.
The car's long gone.
Now,
Would he fix it for free?
probably a lot less than what it was supposed to be fixed for. My dad likes stuff like that. That's his hobby.
I gotcha. Part C is where it gets dicier. I can't be bought off for that
Why?
because I don't get bought off. What percent of boys prefer a sports car? Now, this is where it gets a little dicier. Read part C. What percent of the boys prefer a sports car? What the question is implying. 100% correct. Yes, you're 100% correct. When they say of boys, you are only looking at the 60 guys that participated in the survey. You're only looking at the guys. Of the 60 guys, 21 preferred an SUV and 39 preferred a sports car. So because of the way that this question is worded, part C has to be, well, there's 39 guys who preferred a sports car out of the 60. Yes, that is how you are to do this question. 65%. That's coincidental. Let's look at part D. Of those who preferred a sports car, meaning you are only looking at the sports car preferences, percent were girls. Yes. That's where this table gets a little dicier. But yes, what you just said, there are 45 females who preferred sports cars out of 84 people who preferred sports cars. That's why they say of those who preferred sports cars, meaning you're only looking at the sports car column. What percent were girls? 45 out of 84, which that's a weird percentage. 53.6% is what it rounds to. I was hoping it'd be a nice like round number again, but I guess not. They didn't want to make me happy there. You know what's really cool about Carvana? Like, you know, you guys talk about like there's like a vending machine feature or whatever if you go to like one of those places. Well, we bought it during COVID. So we couldn't like go travel to Pennsylvania and go do that or wherever the Carvana was. We ordered it on a Thursday night. They delivered it the very next day. It was in Pennsylvania somewhere. They drove it out to Manahawkin the very next day. Like, oh, snap. That's amazing. Maybe. Well, initially before we purchased it, they were just like, well, it could arrive in like 7 to 10 business days or something like that. And then we purchased it and they're like, oh, let's set up a delivery. Is tomorrow good? I'm like, yes. It's amazing. They delivered that on a flatbed. It was great. Anyway, number 6. Solve 5x plus 6 equals 2x plus 2, but they do want you to leave your answer as an improper fraction. I feel like after the school year that we've had, if you get a problem like this on the final exam, this should be like found money. It legitimately should be. Should be, theoretically. If you get a problem like this on the final exam after like the last 14 months, it's like, oh, and now I'm getting 1 right. Subtract the 2x, subtract the 6. 3x equals -4. They say to leave it as an improper fraction, so x equals -4 over 3. That's amazing. Again, like the Algebra 2 teachers put the Linkit assessment together kind of in a conglomeration. So like each of us were responsible for a different section of problems. I don't know what other problems they kind of put on there onto the Linkit thing because it's like everything's supposedly automatic. But then of course we also put the review together. But like if you get a problem like that, it's like, man, that kind of surprised me how straightforward that. Anyway, that's like pre-algebra stuff. Wunderbar. Let's look at number 7. Here we go. Haha. Expected value. This one, again, is something that I can explain fairly straightforward to you. There's a simple explanation for expected value. It's not something that we have necessarily covered during this particular school year, but it's something that I can easily show you what to do. So I'm going to copy this table down just so I can have it when I actually flip my camera over. Keep referencing it. 0, 1, 2, 3 versus 2, 7, 8, and 3. Okay. A student conducted 20 trials of an experiment in which she flipped a fair coin 3 times. Okay. She created a table of information to record the number of heads that she received. Based on the data in the table, what is the expected value for the number of heads? Well, I'm going to flip my camera here. Here we go. Cool. Now, I'm going to change something about these numbers. There were 20 trials. 20 trials implies the following. There we go. I'm going to have to change the number of trials from that weird number to an actual percentage. 0 heads showed up 10% of the time. 1 heads showed up, and if I actually do this calculation correctly, I believe it should be 35%. Yep, just double checking. Should 35% of the time. 8 heads showed up. It should be 40. Again, just double checking. Yep, 40% of the time. And 3 should have shown up 15% of the time. What has to happen for this problem, it's a weird, convoluted thing. But again, I'm trying to show it to you in the simplest way possible. What I would have to do is I would have to take the number of heads, multiply it by the percentage, which I'll write up here. The number of heads times the percentage, which in this case, I would get 0. I would get 0.35. I would get 0.80. And I would get 0.45. If I actually multiplied those together, the number of heads versus the percentage. So 0 times 0.10, 1 times 0.35, 2 times 0.40, and 3 times 0.15. All I would then have to do is add them all up. It's a weird process, but it's something that you may have seen in the past. If I just add them all up and find the sum, that's actually what the answer is. If you flip a coin 3 times, how many heads are you expecting to get in reality? But like, that's not possible, right? Could be 2, could be 1. I mean, it could be any of those 4, really. But like, yeah, you're right, though. 1.5 is what should happen on average. But clearly, we're not going to get exactly 1.5.
That's why you number of times to do it. It's 6.
Possibly, but then you would expect 3 and 3. But if you do it in an experiment, you might not get exactly 3 and 3. You know? It's a weird thing. It's like the more times you flip it, the more likely the percentage is going to be closer to 50-50. You know?
Well, actually, not even. It's like, I feel like I always get ahead, basically. You know, I rarely get tails.
if it's a fair coin, then according to the law of large numbers, in the long run, your long-term average should be close to 50-50. Yeah, if it's a weighted coin, then that's a different story. You know, have you ever seen the coins that are actually like you can actually like splice them open and there's like stuff hidden inside? Have you seen those? Yeah, I've seen them in like quarters and $half. Well, it's not all of them. They're like specialty coins that made their way into circulation. Yeah.
And like I put it in the register, and I was like, I've never seen a $half before, so I took 2 quarters and I put it in the register and sold it.
When I worked at Walmart for one summer, like 17 years ago, I would always have spare change in my pocket because whenever I saw a wheat penny or I saw like an old nickel or an old dime or an old quarter that I wanted, I would just trade it out. So my tin would always even out. Yeah. You know, because if you have a $half that was minted before 1965, then it should be 90% silver. And it before 1965, it's not silver. 1964, it is. Okay. But if it's 90% silver, then on average, you can get 10 times the face value. Meaning if you take that $half to a coin shop, they might give you $4 or $5 for it. Yeah, but it has to be 90% silver. If it's not, it's just nickel clad and it's just worth like 50 cents. Yeah. Yeah, you gotta know things about money. Anyway. Oh, why not? I know too much about money. Number 8. We'll wrap up with number 8 today. Like I said, this is not the only day. This review is supposed to take us through Tuesday of next week, but we are going to wrap up with number 8 today. Here's the other cool thing about pennies. Ready? First of all, they're not pennies. They don't say the word penny on them. They are cents. Okay. Second, if you have a penny that was minted before 1982, and you slam it on like a flat surface, like throw it straight down on a flat surface, like on its edge, and it bounces, it'll make a pinging noise, like ping, and you hear that pinging noise. If you do the same thing to a penny that was minted after 1982 and do it, that ping will not happen. Because before 1982, they were made out of mostly copper, which has that resonance to the metal. And then after 1982, they're made out of zinc, which doesn't have it. Well, technically, like rocks, metals, you know. I mean, it's mainly a metal, but obviously zinc can be found in rocks. That's where you find most raw metals. So I'm looking at this problem number 8, and I'm going to show you again, in my opinion, quite possibly the easiest way to get this done. First and foremost, I am going to square both sides. The reason why I'm going to square both sides is because I would like to get rid of that square root. However, on the left side, I'm going to have to do something extra special. On the left side, I am going to have to get rid of that square root by multiplying it out in a 2x2 box. On the left side, not the right side. The reason for that is because of the plus sign. Because of that plus sign, I have to treat this like a binomial. So I'm going to multiply it out in that 2x2 box right here. Square root of x times the square root of x becomes the square root of x squared. And because it is the square root of x squared, it just becomes an x. This one is 15 root x. This is 15 root x. And this just becomes a 9, filling out that 2x2 box. On the right side, it will just become a 4x. Because if I square it, that 2 is squared and that square root is squared. So that square root just goes away. The left side, I can't do that because of the plus sign. The plus sign does not allow me to do that. The plus sign forces me to do a 2x2 box. Let me zoom out a little. Scroll this thing up. There we go. On the left side, if I kind of combine these terms, I have a 25x plus, well, it's 15 root x and 15 root x. And I get something like this. This is a really messed up problem. It's a really messed up problem. Only because that plus sign was there. If that plus sign was not there, we would pretty much be done by now. But nope, that plus sign's there, so we do have to keep this problem moving forward. After I combine the terms within that box, again, that 4x is still on the right side. I'm going to move some junk around. I'm going to move it like this. Here we go. I'm going to move the 25x over by subtracting. And I'm going to move that 9 over by subtracting. I subtracted the 25x and I subtracted the 9. That 30 square root of x I just left there. And now, unfortunately, I'm going to have to square it again. By doing this, it's actually going to turn it into a quadratic. Ugh, if only there was a simpler way to get this problem done. Now, I'm going to make a note here. The note that I'm going to make here is this. Tears. Tears. Because, ladies and gentlemen, from here, you would have to get a quadratic, and this quadratic would need to be solved, and this would just end in tears. Did no one see the shortcut at the beginning? There is a massive, massive shortcut at the very, very beginning of this problem. Let me write the problem one more time. 5 square root of x plus 3 equals 2 square root of x. People look at stuff like this and they panic. They absolutely panic. But I need you to recognize a nice little shortcut. And that shortcut is this. Let me subtract the 5 square root of x from both sides. Let me just subtract that. 3 equals. Now, I have 2 square root of x minus 5 square root of x. What is 2 square root of x minus 5 square root of x? Holy crap. Let's square both sides. If I were to square both sides, all of a sudden, can I actually do this? I get 9 equals 9x. X equals 1. Always look for a shortcut. Always look for a shortcut. If there is a shortcut and you're allowed to take it, take the shortcut. This is why this problem, number 8, can either be your worst nightmare or your best friend. We're going to pick up more of this on Friday. If you haven't left a comment in the chat, please make sure they do so. And of course, I am going to be posting that thing on Google Classroom in regards to that quizzes. You'll see that later today. See you. Bye-bye. Have a good one. I'm leaving the chat open for just a moment, just in case people want to leave that comment, in case they haven't. Okay, I gave them that moment.